Hello everyone, I am going to explain some questions from miscellaneous exercise of chapter 7 from 12th maths. Today I am going to explain you question number 11. Question 11th is, if cos inverse bracket x square minus y square upon x square plus y square equal to tan inverse a, then prove that dy over dx is equal to y upon x. So with the help of this given equation we have to bring this, and the meaning of dy over dx is we have to differentiate with respect to x. So first I wrote the given equation, and after writing the given equation, tan inverse a is a constant because here the variables are y and x only, so it's a constant. So I am shifting this cos inverse also in this side to reduce the calculation burden. So when we'll shift this cos inverse in this side, it's going to be cos tan inverse a, and its complete is a constant. So if we'll differentiate, this complete becomes 0. So like this we have to shift it. Now we have to differentiate it with respect to x. So since it's a fraction, so we are going to use the formula of fractions differentiation, that is denominator square, then denominator as it is, differentiation of numerator, and then numerator as it is, and then differentiation of the denominator. So let's see what is denominator here, x square plus y square. So denominator square, then first denominator as it is, first because numerator is there, so first we have to differentiate the numerator, and second term we have to differentiate the denominator. Now here the differentiation of this side was like this. Now in next step, when we differentiate this constant, it becomes 0, and here we have to differentiate. So this bracket as it is. Now when we differentiate it, differentiation of 2x is x to the power 2 is x square. X square's differentiation is 2x, and differentiation of y square is 2y, and then dy over dx, because we have to use the chain rule. So when we use the chain rule, it's going to be dy over dx. So if you are going to use here chain rule, then what will come here, dx over dx, and dx over dx is 1. That's why I not mentioned here. So when we differentiate any function, always chain rule is applicable, but since sometime after using the chain rule it used to be 1, so we not used to show it, like x square. If we differentiate x square with the help of x to the power n formula, we'll get 2x, and further if we differentiate only x, we'll get 1. But when we differentiate y square differentiation is 2y, and now when we'll apply the chain rule, we have to differentiate this y also, that will give us dy over dx. And now this term as it is, now we'll differentiate this x square plus y square, same way we'll obtain this after applying the chain rule. Now since our target is to bring dy over dx, so we'll try to keep it alone. So for that, first in next step, this denominator will shift here. So this denominator here is in division, so when it will come, it will multiply by 0 and get 0. So just see this, I not mentioned the denominator here because I already shifted and it got 0. Now here you can see in this bracket also 2 common, and here also 2 common. So when we take 2 common, that 2 is in multiply. So that 2 when we will go with 0, it becomes also 0. So just see, I remove 2 from both the brackets here. Now what we have to do is, our target is to bring dy over dx separate. That's why we have to open the bracket. We are going to open the bracket. When we multiply it by x, we will get x bracket x square plus y square, and this y as it is, and this bracket will attach with it. In the same way we will open it by taking care of minus sign, we will obtain this. Now what we have to do is, here also x and here also x. So from this first term and from third term, take x common. So you will get x square plus y square here, and when you will multiply by minus, sign will change. Now these both terms, you just shift in right hand side, you will obtain this, and take to y and dy over dx common, you will get this. Now do plus minus in the bracket, you will get this, and since we want dy over dx, so shift this y to x square in other side. Now cancel them, that will give you y upon x. That is our required result. So in this question, the starting step is very important, that you should take care that you have to shift the cos inverse in the other side, so that your calculation get reduced, unless this question is going to be very complicated. That's why starting take care of the starting of this question. Now we'll move to the question number 12 of same exercise, that is miscellaneous of chapter 7. Now again equation is given to us. With the help of this given equation we have to prove this. So whatever we have to prove, we'll observe it very carefully. What we found is, here we have to bring sine square a plus y, and it is already available here, sine bracket a plus y. And square happened. That's why we'll try to convert the given equation in a fraction form, so that when we differentiate it, automatically denominator square we have to do. That's why students, after writing the given equation, I tried to convert it in the fraction so that sine square a plus y can come easily in the answer. So I hope this step is clear why we have done like this, to bring this sine square a plus y. Now we have to differentiate it with respect to x. So same formula of fraction, that is denominator square, then denominator as it is, numerator differentiation, then numerator as it is, denominator differentiation, and then x differentiation is 1 in the right hand side. Now we'll differentiate it. So this sine a plus y as it is, sine y differentiation is cos y, then we'll apply the chain rule. Now sine y as it is, and cos a plus y differentiation, sine a plus y differentiation is cos a plus y. We'll apply the chain rule in the bracket. So when we differentiate this a is a constant, so it's 0, and y differentiation is dy over dx. Then denominator square. Now we'll shift this denominator square in this side, so it will multiply by 1 and become sine square a plus y in right hand side. And from the left hand side we want dy over dx, so we'll separate dy over dx, the remaining terms in the bracket. Now in the bracket whatever arrived, we'll observe it carefully and we'll find that it is in the form of sin a cos b, then cos a sin b. You see the formula, what the formula is? Sin a minus b is sin a cos b, then cos a sin b. So all these terms are satisfying this condition, and its formula is sin a minus b. That's why in the big bracket I used the formula sin a minus b. So this a plus y I assumed as a, and this is b. Now in next step, simplify it, and you will obtain only sin a. Sin a is in multiply, so shift it, you will get the required result. So in this question, again the starting is very important. Starting we have to take care that if we obtain this kind of question, first we have to see the required result. What is the required result? And according to required result, initially we have to do some adjustment. After doing that adjustment, then start to differentiate it, you will obtain the required result. Further, if you have any doubt, you can write in the comment, so that we'll try to remove it. Thank you.